Good morning from Amsterdam. My name is Peter Green and I'll be your host today for the final session of CurioCity Serverless Computing. Before I begin today, I just wanted to call out a big thank you to the senior leadership team of Oracle Digital for sponsoring this event. It's been an amazing event, and all my hub leader colleagues around the different regions that have gone first before me and paved the way to new learning and fueling the quest for the thirst of knowledge. So thank you to Giovanna, thank you to Alan, and actually the big crew that sits behind putting this type of event together. And the support crew here in the Amsterdam hub, Tatiana, Karina, and all the facilities people that have really made this happen today. So thank you. So today I want to introduce a few little facts about Amsterdam. And as you know, I'm from Australia, so I've learnt a lot about Dutch culture since I've moved here. Few things we all know: the Dutch masters, amazing galleries here, amazing artistic creations that house themselves here in Amsterdam. The second thing, home of Heineken, very important, world export of beer. There's more bicycles than people in Amsterdam. Often I try not to get myself run over on a daily basis here. And the city is actually at least 5 meters underwater, I think 13 meters in certain areas of Holland. So the technology that sits behind actually running this city is incredible to keep us afloat, I guess. So the next thing I wanted to do today is I wanted to introduce our guest speaker, Bert Ertman, who is a fellow and director at Outreach for Technology Outreach at Luminous. But before we start our presentation today from Bert, I wanted to introduce some guests that we have, a dance crew here. They're going to do a mixture of traditional dance and modern dance. And as you know, Holland is very famous for dance music. So without further ado, I'm going to introduce, now please forgive my pronunciation, Pira Machoy. I tried, to the stage. So welcome. So thank you very much to our guests. That was really fabulous. That dance that they performed today was about 150 years old, pieces of it. So, and as I understand, Dutch dancing goes back way before that. So really, thank you very much. So talking about serverless computing, fueling innovation, a new way to think about cloud technology, I'm going to introduce Bert to the audience, and he can start to fuel your quest for thirst for knowledge around serverless. Welcome.
I'm not sure if I can top that, but as a real Dutchman, I want you to know that I climbed out of my windmill this morning, drove over here to Amsterdam, brought cheese for all of you, and the only thing I forgot to wear my wooden shoes today. But yeah. All right, so I'm probably better off talking about serverless. So as Peter already introduced me, my name is Bert Ertman. I work for a company called Luminous here in the Netherlands, but we're also based in the US and the UK. And I want to talk about serverless. So the story starts about 4 years ago. It starts when Werner Vogels, the CTO of AWS, he coined this quote at a conference somewhere where he said, "No server is easier to manage than no server at all," which is absolutely true. So what he's trying to say is, would it be possible to take the servers out of the equation? Because nowadays we spend a lot of time setting up servers, installing them, scaling them, maintaining them, patching them, etc. And all we really want to do is run software, right? So the thing is, can we imagine computing without thinking in terms of computers or servers in this case? Well, some might say that's called virtualization. It's already there, right? It's running on virtual computers, which are not like real computers. And the finest form of virtualization is in the cloud. But let's be honest here. So far, the cloud has been a little bit disappointing when it comes to really higher level services that it offered. To some, like on the bumper sticker here, the cloud is just somebody else's computer at the other end of the internet. So if we imagine the cloud, we imagine it's maybe something like this, right? We're still thinking in terms of computers, but then they are virtualized at the other end of the internet. And somehow there's something wrong with that concept. So we came all this way with computer science, maybe for 50, 60 years, and we're still thinking in terms of a single computer, with a computer being a collection of CPU, memory, bit of disk, bit of I/O, right? So what if we can imagine computing without computers? So let me explain to you why the concept of a computer is limiting us or holding us back somehow. I think it is because a computer somehow resembles a pet. Right? So as you see over here. So at first, when you get a new computer, whether it's a physical one or a virtual one at the other end of the internet, it's like getting a new pet. I mean, it's shiny, it's adorable, right? Right? So, and the first thing you do is you give it a name, right? Same thing with computer. You get a new computer, you give it a name. And then you start, taking care of it, which is fun to do at first. But then you have to walk the dog out when it's raining. You have to go to the vet. And after a while, it's going to be a little bit of a drag, right? And so at some point, your pet is going to be sluggish, and it's going to be the same with computers, right? And then at some point, it's going to die, and we are really upset. It's the same with computers. If your computer dies, you get really upset. So somehow this idea of treating computers like we treat pets is a bad idea. So let's think of computers as a group of animals instead. So that's why the cow is over here. So think of a computer or a set of computers as cattle. The thing with cattle is that we are not so much interested in the individual animal, but we are interested in what they produce. And in the case of cows, it's going to be milk, right? So the produce is milk. Now let's translate this concept to computers. So if we have to imagine the produce of a computer, the only thing we have to do is take the last letter off, right? So let's saw the last letter of the word off. And now instead of thinking in computers, let's think in compute. And let's think about compute the same way we think about taking electricity from a wall socket, for example, right? So whenever you want to switch a lamp on, We plug it into the wall socket, we take a bit of electricity, and we make the lamp go on. If we want the lamp go off, we unplug it from the wall socket, and then the lamp is off. So what if we could translate this concept to computers? And so we could take compute out of the wall socket. So whenever we want to run software for a while, we plug it into the wall socket, and then we take some virtualized computers or compute from the wall socket. And whenever we're done running the software, we just unplug it, and we're no longer consuming any compute. Now, this is exactly the concept of serverless. So if we take the servers and the computers out of the equation, all that is left is building software. And as we build software, we have to write business rules. And business rules is basically creating functions. And functions take some input at the top. So something interesting happens, which we just shove into a function. Then within the function, we do something interesting with it. And then we produce some interesting output. So instead of thinking in applications as a bigger concept, we are just going to more fine-grained granularity, where we're thinking in smaller functions. So the function is the lamp in this case, right? I can just plug it into the wall socket when I need some compute, and when I'm done running it, I just unplug it. At the heart of this programming model are events. And events is like something interesting is happening here. And so I want to notify my function and pass on the event as an input. And then I have an example over here. I'll make the function run. So I have an example over here on the left-hand side. You see somebody updates or inserts a record into a database, for example, right? Now, this is something interesting because we are manipulating some entity or whatever. So we fire off an event from that database. Then on the right-hand side, we have a function responding to that particular event, and then we can run some code in response to this event, which can then, well, check on the data being updated, distribute that data to other data sources, for example, or maybe even modify that data. Now, this looks a lot like a familiar concept that we already know from the database world, which is called triggers. And so, in a very basic sense, serverless is exactly like triggers. But then, it doesn't really have to operate just on databases alone. So here's another example. So let's imagine a file store somewhere, maybe in the cloud, right? So somebody uploads a file. And then when they're done uploading, that will fire off an event. There's a new file. And then a function is being triggered, taking the file as input, maybe processing it, or maybe notifying someone that there is a new file incoming. So then you can do something interesting with that file. Okay, two simple examples. But now here comes the catch with serverless. What happens if I got lots of uploads? So on the left-hand side, you see people uploading lots of files simultaneously. Then on the right-hand side, or in the middle actually, you see this file store firing off events. And these events, there will be many events. So there will be as much event as there's incoming files. On the right-hand side, you see that there will be a lot of functions running. So there's one running function for each event being emitted. And here is the magic of serverless, because now it's up to the cloud provider providing us this serverless platform to scale. So we no longer have to install like a battery of servers which do nothing for most of the time, just waiting for that one load spike to hit, right, and then scale everything out. But in this case, the cloud provider is automatically scaling this for us. So if there's lots of incoming traffic, we get lots of events, and lots of events will be translated to lots of running services. So as a programmer, I only have to think of writing this function once, and then I define a trigger for it, and then the cloud provider will automatically scale this for me. So I can never under or over provision servers again. And the best thing is, I only pay for when stuff is actually being ran. So I only pay for all the functions that run here, which maybe take a second or less to process this file, instead of having this huge array of servers doing nothing most of the time, which I will pay for all of the time. So just a quick summary. Serverless abstracts the infrastructure and all the servers and computers away, which allows me to just concentrate on writing code. So I can start experiments, I can start responding to certain interesting things happening, and this allows for a culture of innovation and experimentation within your company, right? Because there's no need to manage and patch and deal with servers all the time, it just frees up time, right? So that's actually good. and less to worry about because the cloud provider running this infrastructure for me will take care of scaling and running this. So that's actually a very good thing to do. And I can now no longer under or over provision stuff. This is all being taken care of by the cloud. And the best thing maybe is I only pay for what I actually use. So this is true pay-as-you-go model, which we haven't seen before in the cloud, basically. All right. Well, this all sounds too good to be true, right? And so we have to be careful not to fall for the hammer and nail syndrome, which is like if the only thing you have is a hammer, then everything starts to look like a nail, right? So we should think of, are all scenarios ever going to be suitable for this serverless thing, or are there any specific use cases which are really, really good for serverless? And I think the latter is the case. So let's look at a few examples here, some real life examples of companies actually using this in production right now. The first scenario here is Expedia. You probably all know Expedia, right? It's like a Google for hotels, search, car rentals, whatever. So basically you see a search prompt and then you type in the name of a city and then you get all sorts of suggestions for hotels, flights, car rentals, whatever. Now Expedia started experimenting with this serverless technology about a year or two ago. And what they did is they took some of their workloads and moved them from traditional data center workloads to serverless-based workloads. And they basically run a lot now. So the numbers on this slide say that they do about 2.5 billion computations per month. So a computation is one function running in this case. So that's quite a lot of functions. And that comes down to about 200K compute hours. Now 200K compute hours, if you do some quick math, is about 40 computers running at 100% CPU. And this is, well, that's not a wise thing to do, running everything at 100% CPU. So if you spread that out over multiple computers, it's probably somewhere between 100 and 200 computers running this workload. And that's like, well, maybe half a data center, third of a data center. So that's, quite some power that there is behind these computations here. Now, the most staggering number on this slide is the bottom one, because that is the bill that they pay to their cloud provider every month. And this is just over $500 a month, right? So that's a lot of computation, which comes down to operating half a data center, which now costs them a little over $500 a month. So this is quite a disruption for them, right, in terms of their bill, right? So not suitable for all use cases, but in this specific use case, they save a lot of money by going serverless. And they also save half a data center and everything that comes along with it. Another example is Thomson Reuters, which is a news company, as you know. And so Thomson is dealing with the news. The thing about the news is it's hard to predict. So whenever something interesting happens, people go out in the field, they make like documentaries or they make like little videos, and then they upload these videos to a file server somewhere. Now, these raw video materials that come in have to be transcoded for them so they can use them on other media. So transcoding a video is mostly a one-to-one process, right? So you upload like a 5-minute file, it takes about 5 minutes to process. You upload a 1-hour file, it takes about an hour to process. So that doesn't really scale well, especially not if something interesting is happening or if there's like a lot of news, right? So there's lots and lots of files coming in. So if you have to develop a traditional solution to deal with this, it's going to be costly and it needs to be scaled over a lot of computers. So what they did is, instead of going for a traditional solution, they take the incoming file, let's say it's a 10-minute video being uploaded, and then they fire off an event. They say, well, there's a new file incoming, and then there's this function, and that will check whether it's a video file, and if it's a video file, it will chop it up into a lot of pieces. So it chops it up into, say, 1-second pieces, right? So 10-minute file goes into a lot of 1-second pieces. Then it writes that output, so all of those small pieces go into another folder. And on this folder, there's another trigger that says, if there's an incoming video piece of, say, a second, then we'll start transcoding these segments. So all of these 1-second segments will be transcoded by function. And I said there's a 1-to-1 ratio. So transcoding 1 second takes about 1 second, right? But this goes in parallel because it's cutting it up, then dumping it all into this folder. And now we see a massive parallelization going on. And then the transcoded segments go into another folder, right? So they are almost ready to use. So the only thing they do is they need to join them using another function into a completely transcoded video file. Now, instead of this video taking 10 minutes to transcode, it now takes a little bit over a few seconds, right? Because we do massive parallelization here. And once again, if I had to build a traditional solution for this, it would involve a lot of servers dealing with server maintenance all the time. I need to be ready to handle peak loads, lots of incoming files. And now, because all of the interesting stuff is being done in functions, they heavily rely on their cloud provider to elastically scale up when there's lots of videos coming in. And if there's no videos coming in, then nothing is doing anything, and they pay for nothing, right? Which is a fair model. Another example, iRobot, which is the company behind these robot vacuum cleaners. At some point in time, they ran a big promotion. I think it was like a Black Friday sale, and they had lots of consumers buying these robots at once. And iRobot is a hardware company, so they're really good building these robots, but they're probably, well, not really good at scaling software. So the vacuum cleaning in their house, but then they had lots of new customers doing the sign-up process for their new robots. And this sign-up process was taking its toll on their servers. So in order to deal with all of the incoming sign-ups, right, they had a denial of service because some of their existing customers could not use the normal workflows because their servers were overloaded with new sign-ups. So taking the sign-up routine off of the traditional workflow, of the normal workflow, and dealing with it in a serverless way is something which will auto-scale the sign-ups and will no longer affect the normal workflows. So this is once again a really interesting scenario to deal with serverless technology. The other thing where serverless is really good in is in IoT to mobile communication, because this is, well, unpredictable communication. So a user takes the app and wants to start a vacuum routine right now. Let's take the app and gives it some command or some order, right? Which is then being routed through their cloud service, and through function, they scale this up and then communicate with the IoT device being the vacuum cleaning robot. And the other way around as well. If the robots emit some sensor data to their servers, it will auto-scale using the functions. And then some of this will be fed back into the mobile app, and some of it will be fed back into some backend logic running in the cloud. Right? So for IoT scenarios, this is also really interesting stuff to deal with. Another interesting scenario is mobile application development. Because as a mobile developer, I'm probably really good at developing mobile apps. I'm probably not so good at dealing with running servers all day. So if I have an interesting application, there's got to be some backend logic that goes beside that. So in the backend, there are certain functions that maybe store something in a database somewhere. And instead of having a whole array of servers and being able to set them up and deal with them and patch them if there's like security vulnerabilities, and being able to effectively scale them, predicting load spikes and everything, I can now offload all of this to my cloud provider by just providing the backend logic. And then the mobile application can just use, for example, REST or HTTP connectivity to call in a backend on a certain API endpoint, on an API gateway somewhere over here. And this will be translated into a function call. And if there's lots of incoming traffic, the cloud provider will automatically scale this layer, and the database is also being scaled by the cloud provider. Right? So this is also a really interesting scenario. Even better yet, if I'm a mobile developer and I'm creating a mobile app for iOS, I'll probably do it in a language like Swift, which is geared towards building mobile applications. Now, some of the cloud providers offering serverless functionality also offer you the possibility to run your own programming runtime for functions. So in that case, if I can just do Swift programming, I can now also write my backend routines in Swift. So this is really easy for me as an iOS developer, for example. Right? But this is cool stuff. Now that brings us to the next scenario, which requires a little bit of audience participation. So please take out your phone and go to the URL listed on this slide. It's lumen.is/serverless demo. Make sure you spell it right. And whenever you open the web page, it will ask you for permission to open the camera, so which is safe to do, right? So just snap a picture of yourself, and then it will upload a picture to my function. So let me do it too, right? So you don't have to be afraid of it. It's not doing anything nasty to your Facebook profiles or anything. So lumen.is/serverless demo. Here we go. Here we go. Just take a picture. right? Okay, very good. And now we go to the result page. Oh, there we go. So what I did to your picture is I basically made you all look funny, right? So we uploaded the picture to some cloud file storage somewhere. Then it takes the picture which comes in, fires off a function which then does face detection on it. So to figure out whether there's a face in the picture, and whenever it finds one or more faces, as you can see on the top picture over there, whenever you find one or more faces, it tries to draw like a funny, crazy head on top of them, a little bit Snapchat alike. And well, just to make fun of all of you, then we can scroll down, right? Oh, there's lots of people here with heads. So it's working great, right? All right, so there's lots of people watching this, so that's actually really, really good. Okay, perfect, perfect. You see, that's the power of serverless. I can make you all look funny. All right, if you want to see the result for yourself, just use the same URL and then type result at the end, and this will give you the picture which you can then download and blackmail your colleagues with, right? All right, so there we go. Now coming back to my previous scenario, right? And this is basically also what's running underneath the application that you've just been using. So what if we could make the middleware, which is still in this picture, like a database and an API gateway? What if we could make that serverless too, right? So instead of, well, that only leaves me with building some front-end functionality, which can be a web application or a mobile application, and then one or more functions in the background. Right? Well, in fact, we are already there. So most cloud providers offering you a serverless platform also offer you the option to run some sort of serverless middleware. So in this case, the API gateway over here is not something that I've set up myself. So I haven't installed an API gateway on a server somewhere and then try to scale it myself. This is being offered to me by my cloud provider as a serverless middleware service, where I just define an endpoint on the left-hand side, which is like a contract for my application to sign in. And then on the right-hand side, I just point it to a function to run. And it's all also serverless. I'm not running the servers underneath my API gateway. Same thing for the database, right? So instead of installing a database and scaling and replicating it over multiple servers, I've just told my cloud provider, I need data storage. And the schema for the table looks a little bit like this, right? Thanks to the joys of NoSQL and everything, but it could be relational as well. There's also cloud providers offering you serverless relational databases. And so I just told them the schema, and then I said, well, run this for me. I will insert data, I will read on that data, but I want you to optimize and store it for me. So the database provider will then find the optimum storage. It will also figure out how to do indexes and everything. It will even do machine learning on the security model to figure out who can and who cannot access this. So serverless databases, serverless API gateways, serverless message queues, it is already out there. And now, if we don't have to worry about running servers, and we don't have to worry about running infrastructure, that leaves us with just experimenting and developing software, which is, well, lots of time that we can spend better than maintaining our pet or our server. And this also enables a little bit of disruption for the economic model for doing software projects, right? So with this whole advent of cloud came this idea of shifting, capital investments into more operational investments. So instead of, sitting down with lots of people and going up all the way into the hierarchy to get a sign-off to start a new project, which mostly meant buying lots and lots of hardware and then setting up a team, and then, before you start, you're already losing lots and lots of money, right? And then you have this write-off period. But now, since the cloud provider is doing all the heavy lifting for us, we can almost start with like zero upfront investment. We just take an existing database in the cloud somewhere and we say, well, what if somebody inserted a new record? Well, then we point it to an event, which will then point to a function, and we can literally start experimenting in minutes. Write a function, deploy it in the cloud, see what happens, right? And then we connect an API gateway and we connect message buses to it and everything, right? Because all of this stuff is serverless, you can easily switch it on. If you go over a certain threshold, you start paying for it, but only tiny bits, because you only pay when you are actually using this. So for the experimentation phase, it's hardly zero upfront investment that you have. And then when you like the whole idea, you just push it into production, and then you have the power of your cloud provider running it for you. So basically interesting. Now, to get a little bit of, to get a little bit philosophical here, if you think about this whole idea of taking compute and now also middleware from the wall socket, maybe we're on the verge of something here. Maybe, in hindsight, let's say 5 or 10 years from now, we were, with serverless, we were at the advent of the next industrial revolution. Because if you think about it, we had the steam machine, then we had electricity, which then created mass production. Then we had automation, right? And now we have serverless. And serverless is to automation, in my opinion, what electricity was to the steam machine back in the days, right? So with this stuff, taking it from the wall socket, right, we're on the verge of something huge. It's not perfect yet. It's still very young. It's only 3-4 years old. But there's so much innovation happening in this space right now that I think in 5 or 10 years from now, we were in this, transition into the next industrial revolution. So I believe in serverless. I believe that it will definitely change the cloud as we know it. It is already changing the cloud as we know it. So I threw away all of my computers at home, and I hope you do too. Thank you very much.
Bert, thank you very much. Anybody from the audience have any questions for Bert today?
Hi, I have 2 questions. Does it work? Yeah. First of all, you showed some use cases. What kind of companies do you see right now going towards the serverless trend? Is it more like startups that don't want to do upfront investment, or is it corporate companies that can't handle the workloads anymore? And that's my first question. And the second one, if you want to go serverless, what do you have to look for in that in a serverless provider? Like, what's important?
Okay. So coming back to that first question, I think it's all sorts of companies doing it for different reasons. So with startups, for example, there's usually like a little shortage of money, right? So they want to pay for a huge array of servers if these servers do mostly nothing, right? So this is perfect for a startup to go from startup to scale-up phase, because they don't spend a lot of money on running hardware. So for startups, it's fine. For enterprise companies at the other end of the spectrum, this is also interesting because, as I pointed out, it is enabling a culture of innovation. And for some enterprises, for them, it's really hard to start innovating because they have to go to really tough decision-making processes to start something new. Now, with this technology, it is really easy to start experimenting, as I just pointed out, because everything is just a single click to turn it on and then a single click to turn it off again. So there's no heavy costs involved, and it really fosters a culture of innovation and experimentation. In the middle, like for medium and small businesses, it is maybe enabling stuff to them, which was up until now only available to enterprise companies. Because experimenting with databases which auto-scale in the cloud and message queues with auto-scale and handling like thousands of simultaneous uploads and then just paying like a couple cents for it, that was something which was, well, only available to big enterprises with deep pockets. But now, since it's just a game of cents and pennies, right, it's also available for medium and small businesses. So I think it is interesting to all sorts of businesses. And your second questions, so what do you have to look for in a cloud provider in order to get started with this? Well, most of the major cloud providers are already offering a serverless platform. And while they all have their proprietary ways to do it, the concepts are behind all of them are like the ones that I have just explained. So with all of them, whichever one you pick, you can start creating functions and then hook them up to interesting events happening here and there. And then they vary in terms of how many middleware services they have already enabled to fire off events, or how many of these middleware services are already serverless. But right now, there's this innovation battle going on between cloud vendors, and all of them are really stepping in because this is where it's going. Okay, does that answer the question? Okay, welcome.
So we're running a little bit over time. So if I can ask everybody just to divert their questions for Bert to Slack. Bert's going to hang around for a little while and answer some questions on Slack for us today. Bert is internationally published and is frequently on the global speaking circuit, so you can find a lot of his information published, so I encourage you to do that. And I want to thank everybody for joining, and could we thank Bert for joining us here in the Amsterdam hub today, and obviously globally around all the hubs, so thank you. Thank you, Bert.
Yeah, welcome.
So we're just going to announce the winner from the Dubai competition. So I just have the randomizer here. So I'm going to pick a random number and then we'll see who that is. Okay. Can you see it there? So it's number 2. So let's see. Yeah. Cool. So who's that number 2? Oh. That is, so it's Frank Bradley, so congratulations. You've won yourself a Google Home Mini. I'll just say one quick thing as well. We have a blog coming out, so that's going to be in the next 2 weeks. It's going to be on serverless computing, and we're going to bring in other technologies that we covered as well. So just have a look on OD Curiosity for that, the Slack channel. Okay, slides gone. Thanks, I'll hand you back to Peter now. So.
Okay, once again, thank you everybody for joining. Thanks again to Bert. It's been a great end of the Curio series, and looking forward to the next Curio kickoff when and if that happens. I'm sure it will. So thanks again. Thank you.